interrupt me. All right, so this is our starter for Monday. Again, the numbering is really off. So this is Monday number 1, but it's a screenshot in your workbook, so that's why it's 11A, whatever. So let's look. So we have 1 minus 1 over x plus 3. And if you forgot, we learned about exponents recently, then we learned about logs. Now we're in rational functions. Technically, this is called rational functions. Now, when we're dealing with rational functions, we have a parent function. And the parent function is y equals 1 over x. Just like with exponentials, you started off, I think, with like 2x, or with logs, 2 squared or something like that. And then with logs, you start with like log base b argument x. Okay, whatever. So your parent function always has the same starting points, the anchor points. You guys are probably used to just seeing 2 points, but because the graph looks like this, there's technically 2 graphs in the picture. That's the parent graph. The black highlighted is the parent graph. So that's why they give you 3 points to accurately plot this parent graph and 3 points down here. So that's why the anchor points, there's 6 of them instead of like 2. Where like with logs, you only had 2 anchor points, but now you guys have 6. So the way I memorize it is like this. Okay, the first point, now my x and my y-axis, they're the green ones, right? So let's not look at the blue, let's not look at the red yet. Let's just look at the green. Basic y-axis starting at, x equals 0. The x-axis starting at y equals 0. So the anchor point is 1, 1. And then you go up to 2 at the halfway mark. And then you go down to 2 at the halfway mark. So there's my -1, -1. You go down to 2 at the halfway mark, and then you go up to 2 at the halfway mark. So that's just how I remember the anchor points. Okay, period 1. Are you following me? Yeah. So far, okay? Yeah, the asymptotes. Yeah, and so the asymptotes in the parent function are directly on the axes. So the horizontal asymptote is always going to be this horizontal asymptote is the x-axis. And the x-axis, some of us learned this last week, the x-axis does not mean x equals 0. The x-axis means y equals 0. Y equals 0, okay? And the vertical asymptote is the y-axis. And remember, the y-axis is not y equals 0. The y-axis is x equals 0. So that's where I get my asymptotes. Now, I forgot to tell you about the transformations on the parent function. So if we're getting multiplied by a negative value, that's our a value. That means the graph is going to get reflected. If we are subtracting an h value, that means that the graph is going to get shifted to the right if it's being subtracted. If it's being added, it's going to shift to the left. It's the opposite, kind of like parabolas. Not kind of like, exactly like quadratics and parabolas. Now the k value, it could show up after the parent function, or it could show up before the parent function, and that's just a shift up or a shift down. Kind of like here, the 1 shows up in front of the parent function, but the 1 itself is positive. I heard some people asking, like, is that negative on the 1? Well, technically that negative is on the 1, but it's on this one, making the a value negative, not the k value. The k value remains positive, so that means we're going to move up 1. One thing that my period 1 just called out, which I forgot, is over here, I forgot to put the negatives. So it's -1/2, -2, -2, -1/2. So I'm going to put those negatives right there in red so that you can make sure that you write that correct. All right, cool. So graphing these is very, there's just a lot of steps. So my suggestion to you is to figure out where the vertical asymptote and the horizontal asymptote go. So if you look at my lightsaber, the horizontal asymptote is always attached to your y value. Your horizontal asymptote is attached to your k value, because your k value determines if the graph shifts up or down. So the k value is attached to your y value. So if your k is 1, that means your horizontal asymptote is now y equals 1. So y and k are attached. And then the vertical asymptote is attached to your h value. So if your h value has shifted, your vertical asymptote has also shifted. Okay, so let's start with the horizontal asymptote. We went from y equals 0, which would be right here where the x-axis is, to y equals 1. So y equals 1 is now here. That is where my graph is shifting, okay? And then my vertical asymptote went from x equals 0, which is here, x equals 0 here, shifted 3 to the left. 1, 2, 3. There's my vertical asymptote. Okay, now half of the work has been done. You figured out where the asymptotes are. So now look at the parent function. At the parent function, we are, remember, the asymptotes are the green lines for the parent function. We went up 1 at 1, 1, right here. So there, it's 1 away from both asymptotes. So if you look at our new asymptotes, our point would be right here. However, we were reflected. We reflected on the x-axis. So if we reflect this point, it should be here on our parent function. And now I just remind myself, okay, I have to be 2 away at the halfway mark. I have to be 2 away at the halfway mark. And I just sketch those 2 points right there. And then I draw my parent function. Now let's look at the other parent function right here. This is 1 and 1 away from the asymptotes. So now in my new graph, it's 1 and 1 away. But since it's reflected, I'm going to reflect it on the x-axis. It ends up here. All right, so I got a suggestion to write it as I'm saying it. So here we go. So I went from this point right here on my parent function, 1, 1, to shifting it from my asymptote to here, right? But that's not my point. My point has to be reflected on the x-axis. So I'm going to reflect it to this point right here. And then I'm going to go 2 away from the asymptote. So 2 away from the asymptote at the halfway point, and then plot that point. And then in the same manner, 2 away from the asymptote at the halfway mark, and then graph this. I'm going to go ahead and do number 2 with you as well. So I'll record that video as well. And then again, I went 1, 1. I mean, it was down here, but then I reflected it. So now it's up here. And then I have another point here, another point here. And then I graph that. And that is the new transformed function. All right, I'm going to re-explain everything I just said. Sorry for the redundancy, but some of us need it. So the parent function, oh my God, that's so sloppy, is y equals 1 over x, okay? So we know that our anchor points are 1, 1, and -1, -1. We know that it's 2, 1/2, and -2, -1/2. I think I'm saying them out of order, but it's fine. And then we have 1/2, 2, and -1/2, 2. Period 1. Are we good with that so far?
Yeah.
Okay, cool. So if I look at my A, H, and K in my new function, oh wait, our horizontal asymptote is what? No, like usually.
It's just
Is y equals 0? And then our vertical asymptote is x equals 0. Okay, and our y value is attached to what letter? Okay, and then our vertical asymptote is attached to our h. Okay, just little things to remember. So let's look at B. What is our A value? +3, so that means there's no reflection going on. Okay, cool. But there is a stretch of 3, so there is going to be a stretch. So make sure you're writing this down if you're in my class and you don't have number 2 done on your starter. Okay, what is our h value? No, our h is what's attached to the x. It's 4 because it's -4, so it's going to be +4. And that means there's going to be, it's going to go to the right, 4. And then our k value is -2, so what does that mean? Down 2. Okay, so I'm going to draw my x and my y axis. So here's my y-axis. Here's my x-axis. Oh, that's terrible. Draw it one more time. Here's my x-axis. And remember, my parent function is going to be here, here, here. And I'm just drawing that so we have a reference. Here, here, here. This is our parent, okay? You do not have to draw the parent. That's just there so you can see where it originally was. This is the parent. All right, so now Ines is going to take over, and she's going to explain how to graph an A value of 3, an H value of 4, a K value of -2.
Go. Let me see.
What color do you want?
Okay, I'll start with the asymptotes.
Okay,
So-
sounds good. Oh, yeah, I forgot to write them on the side. Go ahead.
Okay, so first thing I do is I like to break down the equation. So like we already kind of did that over here with our A, H, and K.
Mm-hmm.
So I know that our horizontal asymptote, let me see, horizontal asymptote is Y, which is connected to K, is equal to -2. Because we found that out right here.
Yeah, that's true.
And then we have our vertical asymptote, which is X attached to H is equal to 4. So I always like to find these out first, so that way I know where pretty much what our graph is going to look like. So I also like finding like our main point, because right here this is 0, 0. This is where our asymptotes meet, and this is where our original parent function will never touch. So I like to transform this first before I do any graphing. So if we know we're moving down 2, this main center point is going to move down 2. 1, 2. And then we're going to move 4 to the right. So 1, 2, 3, 4. This center point right here we know is never going to move. And now, according to our asymptotes over here on our left, we know we're going to have a dotted line like this, going up and down, and going side to side. So we know this is where our graph is pretty much never going to touch. Kind of like that. So now I would just graph. So we have an A value of 3. And how you would do this is usually we have anchor points. Usually we have anchor points of 1, 1. This is when our A value is just 1. So the difference with a 3 is you're still going to move over 1, but you're going to go up 3 places instead of just 1. And then obviously vice versa because of the anchor points. So you're going to move over 1, but go down 3 instead. And this is how you're going to stretch your graph. And then I kind of just like freehand it because I know where my asymptotes are. So I know the line's going to get close but never touch. So it's kind of like this. And then you're going to do the same thing down here. You're going to continue going down and going up. And that's how I would usually graph it with the stretch.
Beautiful. You can have my job now.